Hey everyone, and welcome back to another video. Today we're going to be talking about acceleration and free fall. Okay, so we're going to get a little bit more defined terms off of those items. But other than that, I want to start off class with a question. And so, a man drops two spheres at the same time from a fixed height. One sphere is a heavy iron ball, and the other sphere is a light styrofoam ball. Without the presence of air resistance or no air resistance, which ball hits the ground first? The iron ball, the styrofoam ball, or they both hit the ground at the same time? Well, remembering back from our last video, when we saw the bowling ball and the feathers being dropped with air resistance, right? So when there was air in that vacuum chamber, we saw that the bowling ball hit the ground first. However, when they sucked out all of the air inside of the vacuum chamber, we saw that both the feather and the bowling ball hit the ground at the same time. Okay, and so similarly to that, we're going to relate it to this. And so why does that happen? Well, we'll dive into that a little bit more today, but it's because both of those objects are under the same exact acceleration. Okay, so the mass of each of those objects don't necessarily matter on the overall speed when the presence of air or when air resistance is taken out of the equation. So but before we even go into this type of question, because this is where we're going to be ending, let's kind of take a little step back as to know how to determine the velocity of an object. Okay. So I'm going to go all the way actually back up to here, and I'm going to introduce this moving man, okay? Once again, we've been watching this moving man so much, we just got to kind of keep moving forward with it. So the question on here asks, a man starts at rest and accelerates for 2 meters per second, so it's accelerating, for 5 seconds. He starts at 0 meters, fell at the table below. We're not going to look at position, but we are going to fill out velocity. Okay, and so, oops, there we go. And so let's determine what the velocities are going to be at 1 second, 2 seconds, and so on. Okay, so here I have my moving man. Don't mind position. We're just going to be solely looking at velocity. Okay, so I'm just going to play it. Notice the motion of the man, what it looks like it's happening. Okay. So from that, it looked like the man started off slow and started moving faster and faster. So let's see at 1 second what it will look like. Okay, so at 1 second, the man travels a velocity of 2 meters per second. So actually, hold on 1 second. I'm going to say seconds a lot, by the way. There we go. So 2 meters per second. All right, 2 seconds goes by. How fast is he going? Okay, his velocity reads 4 meters per second. Okay, so 4 meters per second. Let's kind of keep moving on. Okay, 3 seconds goes by and he's at 6 meters per second. Are you starting to develop a pattern? Okay, so is he gonna make it? I think he is. Okay, 4 seconds goes by and his velocity is at 8 meters per second, and then and so on. Okay, and so I think based off of this, he doesn't actually get to 5 seconds. He actually stops at 4.5. So we don't know how fast he would be going after that, but we could kind of take a little bit of a guess. So first of all, what do you notice between the relationship between velocity and acceleration? Well, my acceleration is still 2 meters per second, okay? And velocity continues to increase, right, after each second goes by. So similar to the relationship with position and velocity, where we had, let's see if I can draw. No, I can't. That's okay. That's okay. Similarly to what we had right here, every second that goes by, my velocity increases by 2. Okay, and so we could see that this increase after each second that goes by, it's just going to increase by 2. And that's exactly what acceleration is. Easy way of saying it is after each second that goes by, my velocity will increase by a certain factor. So in this case, if this is 2, or 2, the next one's 4, the next one's 6, the next one's 8, we could guess that the last one is going to have a velocity of 10 meters per second. And that would be true. Okay? And so we could kind of even see this in terms of if we were to even clear this entire board. I'm going to start him all the way back here. Let me clear it. And let's even say I gave him an acceleration of 5. How fast do you think the man's going to go in 1 second? Or like, what would his velocity be in 1 second? Okay, so in 1 second, he goes 5 meters per second. Okay, and then in 2 seconds, what about that? He would be going 10 meters per second. So I hope you guys kind of get the gist of what acceleration is. After each second goes by, it's going to increase its velocity by this factor. Okay, and so let's get back to our slides. Not that. There. All right. So let's get back to our slides. So before we even go forward into our final example, let's talk more about free fall. So instead of like a man walking from left to right, free fall is just going in the direction of down, always towards the ground of Earth. So if you were to throw anything up in the air, it would fall to the ground always at a certain acceleration. Anywhere you go, if you drop something, that object is going to fall to the ground at 9.8 meters per second per second. Okay? And so that's what we saw with the bowling ball and the feathers. Both of those objects fell at that particular rate. Okay? So what slowed them down? Or what slowed them down in the first example when there was air involved? Well, the air is harder to move air particles around, which makes the feathers float down and the bowling ball just comes down really fast. So air resistance is going to be a factor in having that fall to the ground. All right. And so, but in most of these cases, we're not going to talk too much about air resistance. So let's talk about this final example and then we'll end for today. So a man drops a rock off a cliff and it takes 3 seconds for it to hit the ground. How fast is the rock going right before it hits the ground? Okay. So let's enter it together. What is going to be the acceleration for all objects here on Earth? It is going to be 9.8 meters per second Okay. So now we know that acceleration does not change. Everything accelerates to the ground at this acceleration. 9.8 meters per second. Okay, 9.8 meters per second. Okay, so now we initially start at rest, so it's at 0. So how fast would our object be traveling if our object is at 1 second? If our object has this acceleration? Well, after 1 second, our object should be traveling at that 9.8 meters per second. Okay. So that's how you determine the first second. How fast would it be going after the second second? Well, you just add a total of 9.8 to it. Meters per second. So you're just adding, oh wait, sorry, it's not another 9.8. It's 19.6, sorry. It would be 19.6 because if I were to enter in my calculator, that 9.8 times 2, okay, or I just continue to add 9.8 after each time, it's going to be 19.6. So I'll let you guys try this last part out. How fast do you think the object will be traveling at exactly 3 seconds? Okay, once again, you could use your calculators. And by using that, I see that I just added one more 9.8 meters per second to that side. So that way I'm going to get a velocity of 29.4 meters per second. And that is going to be how fast my object is going to be traveling at that particular speed with no air resistance, assuming no air resistance. Okay? And that is going to be it for today. So I hope you guys learned a little bit more about freefall and how acceleration affects the velocity of an object. And thank you so much for joining in, and I'll see everybody tomorrow.